Hello class, for today's lesson is about understanding and applying joint variation. And here are the learning targets. First, I can determine the values of the variables x, y, z, and the constant of variation k in equations involving joint variation. And I can apply the concept of joint variation to solve real-life mathematical problems. To define, joint variation is a type of variation in which one quantity varies directly as a product of two or more other quantities. And the equation or formula for joint variation is y equals k x z, or it is read properly as y varies jointly as x and z. Similarly, joint and direct variation have one thing in common in which y varies directly as x, but this time in joint variation we have an additional variable which is z, which means y is still our dependent variable, is dependent to the value or values of x and z given a constant. In relation to concepts in real life, when it comes to joint variation, we can have physics, economics, and mathematics. In physics, the force needed to move an object may vary jointly with its mass and acceleration. So we have here the given formula in which F varies directly as M and A. For economics, the total cost may vary jointly with the number of items and the price per item. So for the formula, we have C varies directly as N and P. And last one for mathematics, the area of a triangle varies jointly with its base and height, in which A is equal to, I mean, A varies directly as B and H. This time, let's try to solve problems in finding the value of k. Now, based on the given, y equals or y varies directly as x and z, or y varies jointly as x and z. Now, if y equals 24, x is equal to 3, and z is equal to 4, find k. So this is just similar to finding k having the direct relation to our earlier topic, but this time it's just we have another variable which is z. So if you write it down based on the formula, so we get to have y equals k x z, y is 24, equals k. K is missing this time, so we have here for x we have 3 and 4. So first, as we multiply the values on this side to get a one unified answer as a coefficient of k. So we have here 24 equals 3 times 4 is 12. So we could just have k times 12 and then divide both sides by 12. So that means the value of k is 2. Since 24 divided by 12 is 2. So basically, in finding k, we could have it like this. K is equal to y over x times z, if you want to have it directly as possible. For next problem here, it is a bit complicated because our x this time is squared. So we read this, or let's write this properly first. So we have y equals kx squared z. So we read this as y varies directly as x squared, or the square of x, and z, or you may read it as y equals or y varies jointly as x squared and z. Now, based on this, we could just have certain changes to x or z perhaps, because again, if we apply this into certain real life concepts, we might encounter formulas involving square or perfect squares or perhaps perfect cubes. Now, based on this, the value of y is 108 equals, we're looking for k, so missing. And then the value of x is 3. But then don't forget to have the square because it is given times, where are we? Z, which is 4. So based on this, we could have 108 equals k. Then 3 squared is 9 times 4. And 108 equals k times 9 times 4 is 36. And divide both sides by 36. So we get to have divided by 36. So the value of k, so cancel, is 3. Now again, if you want to use the shorter method of finding k, so in which you have k equals y over x times z, but this time we must not forget that our x here has a perfect square. So k is equal to 108 over 3 squared times 4, in which similar thing to the left side, we have 108 over 3 squared is 9, and 9 times 4 is 36. So still the same answer. K is 3. Since we know how to find the value of k, this time we now have a part 2 of the problem, in which the one that is being asked is the value of y, given such value of the terms or the variables x and z. But first, let's have the first part. So if y is 72, when x is 6, so we don't have a k this time, so 6 times the value of z is 4. So if you want to do the short formula for k, so we could just have k equals 72 over 6 times 4. And to have it, we have 72 divided by 6 times 4 is 24. And 72 divided by 24 is 3. So the value of our constant is 3. Now based on this, we can now use the value of k to the second part. But this time, let's first write the available values of each variable. K is 3, x is 9, z is 5, y is missing. So we're gonna find the value of the dependent variable. So you have here y equals, where am I? K is 3 times 9 times 5. Now, the good thing about this, similar to the recreation, the operation is just a linear thing of multiplication. So it's just like this, so we could just multiply the numbers right away. So 3 times 9 is 27, and 27 times 5 is 135. So this is our, let me just erase the green thing. So 135. For next problem, let me rewrite this first. We have y equals kx squared z cubed. Now, we have here given y varies jointly or directly as x squared and z cubed. And if y is 108, k is 3, and z is 2 find x. Now the good thing here is that we now already have the value of k, so we could just have this directly as possible. Now here, y is 108 equals, the value of k is 3. We don't have value of x because x is being asked for. But again, don't forget that this one should be an x squared. X squared times the value of z is 2. And again, also, don't forget the cube because this one here is cubed, the perfect cube. Now, first, we have here 108 equals 3. Then x squared, and 2 cubed is 8. And so we have 108 equals 3 times 8 is 24. We have x squared. So divide both sides by 24. 24. Okay, and so we cancel both this one, 24. So we are left with x squared, and 108 divided by 24 is 4.5. Now based on this, if you could still remember the process, or I mean one of the methods in finding the value or values of x through extracting square roots, so we could just have, in order to cancel our perfect square here, or the square symbol, all we need to do is to have the square root. So square root both sides, and then so this one here will be cancelled. So we are left with x. Now, as we do the square root of a number, it is both positive and negative. So the approximate value for the square root of 4.5 is 2.12. Since this is just, estimate value. Since this is an estimate value, so we could just have this symbol. Instead of equal sign, it would look like this. And these are the values of x, positive and negative 2.12. Next is we have y varies jointly as the square of x and the cube of z. So similar thing earlier. So y equals k and then square of x, or x squared, and then cube of z, or z cubed. Now here, if y is 54, x is 3. So again, 3 squared, because you should not forget 2 here. And z is 2 cubed. Let's find k first before we go over to the second part, in which we are going to find the value of y. Now here, let's have this one. 54 equals k. 3 squared is 9. 2 cubed is 8. So if this one here, so 9 times 8 is 72. And then divide both sides by 72. So we have to cancel this one. So okay, so 54 divided by 72 is 3/4, or 0.75. Now based on this, we have certain values of k, 0.75, y is missing, x is 4, and z is 3. So based on this, we are looking for the value of y, so it's just an easy substitution. So we have here 0.75. The value of x is 4. And don't forget the square. And 3. And then it is cubed. So you may just use your calculator for a fast, what do you call this? For a quick computation. So we have 0.75. 4 squared is 16. And 3 cubed is 27. So we have 0.75 times 16 times 27. Wait, 16 times 27 is 324. And this is the value of Ry. Last problem before we go over to the word problems when it comes to joint variations. So you have here y varies jointly as the square of x and the cube of z. Now, if y is 432 equals x is 3, so 3 squared, and then 4 cube. Yeah, let's have this one first before solving for the next part of the problem, in which the one being asked is z. Yeah, so you have here 4. Let's just use the short what do you call this, formula for k. So k equals y over x times z. I remember that our x here has a squared and z has a cube. So y is 432 over x is 3 squared, and we have 4 cubed. Again, you're allowed to use calculator, so for this one I'm just gonna use mine. So 432 divided by 3 squared times 4 cubed, and the answer is still 0.75. Since we know the constant, this time let's go back to the second part of the problem. So let's just write this first. We have k equals 0.75. Y is available, so 1024. X is also available, which is 4. This time z is missing. So if we write this down, we have 1024 equals the value of k, which is 0.75, times x, which is 4, and then squared, because we have here squared, and z cube. Now based on this, let's just use a calculator for this part. Anyway, so we have here 1024 equals 0.75 times 16, so we get to have 12, and then z cube. So divide both sides by 12, so cancel, so we are left with z cube, and then 1024 divided by 12 is 85.3, and then 3 is repeating, so let's just write 85.33. Okay. Yeah, and based on this, earlier we get to have a square root. Where was here we had to have a square root because we have an x squared here, so extracting square root. And this time, since our exponent is 3, so we're gonna have extracting cube roots. So for this one, we have here, okay, cube root. I mean, I know that we haven't discussed radicals yet, but just an advanced thing. So if for square root, we have this one, there is an invisible 2, and but for numbers greater than 2, we get to use the numbers that are now visible. So we have here the cube root of 85.33 and the cube root of z cube. So based on this one, we could cancel. So we have z, and still the same thing, positive and negative. So using our calculator, we get to have the cube root of 85.33. So just an estimation or approximation. So again, we're not gonna use an equal sign. Based here, I know this one here is not applicable. Wait, base here, this is not applicable to negative, so only the positive one. Now we have the approximate value here is 4.4, and this is the approximate value of z. Now, why is it that it's only the positive? Because if we are to have this one only, we have 4.4 cubed. So the result would be 4.4 cubed. The result is 85.184, which is close to 85.33. However, and if we expand this, we get to have 4.4 times 4.4 times 4.4. So based on this, all of them have positive signs. So positive times positive is positive, and positive times positive is also positive. That's why we get to have positive 85.184. However, unlike square roots or extracting square roots, we get to use positive and negative answers. We cannot use negative 4.4 this time. It's because if we are going to expand this, or look at just negative 4.4 as an example, if we are going to expand this, we get to have negative 4.4, negative 4.4, negative 4.4. So the result would be negative times negative is positive, and positive times negative is negative. But the number that we are looking for here is a positive 85.33. That's why a negative 4.4 wouldn't satisfy the given. So as we have negative 85.184 is not applicable. So that's why we only get to use this one. This time, let's have some word problems. Now here, the area of a triangle varies jointly as its base and height. So if we're just gonna base it purely on joint variation, we could just have here area is varies jointly, k, and then base times height. Here, if the area is 60 and then the base is 10 and the height is 12, so we get to have 60 times 10 times of is 120, and then divide both sides by 120. So the value of k is 0.5 or 1/2. Actually, without the use of joint variation, if you are someone who knows the formula of the area of a triangle, it's just like this. Area of a triangle is equal to 1/2 times base times height. This is the equation of the area of a triangle. Now, but of course, not everyone knows each formula in the mathematical world, so that's why joint variation is a great help. Now here, let's have the second part of the problem in which we are going to find the area. So area is missing. We have the value of k, which is 1/2. Where are we? Um, base is 8 and h is 15. So direct substitution. So we could have 1/2 times 8 times 15. Using your calculator, you could just have it right away. 0.5 or 1/2 times 8 times 15, and the answer is 60. Now, since we are talking about area, if you're going to answer 60 alone, then that means this is not that it's wrong, but it's incomplete. So if you have to have a proper unit for this, remember that when we talk about perimeter, so let's just say meter, so we have a certain value. Let's just have 60 meters. For volume, we have cubic meters for 3 cubic. That means if we're gonna talk about area, so based on this, based on our answer, so it should be 60 square meters. Now, since based on the problem, there's no such unit like meter, inch, or whatever, then the proper way of answering this without a certain unit is to have area is equal to 60 square units. For next problem here, we have the volume of a gas varies jointly as its temperature T and pressure P. If V is 200 when T is 50 and P is 4, find V when T is 40 and P is 5. So we get to have V equals K T P. Now, let's just go over with the short formula for the constant. So we have V equals TP. So the value of V here is 200 over T is 50 and P is 4. So K equals 200 and 450 times 4 is also 200. So that means the value of the constant is just 1. Now we have here K is equal to 1. In the second problem, we are here find V. Okay, so find V. So V is missing. T is 40 and P is 5. So easy as it is, you just need to substitute the values. We have here V equals K, which is 1, times T is 40 and P is 5. So 1 times 40 times 5 is 200, and this is our answer. However, since we're looking for the volume of gas and there's no, what do you call this, there's no certain label or unit, so we're going to write it like this. So we get to write this as 200 cubic units. Now it should be in cubic units because we are dealing with volume, and volume is cubic in nature. For our last problem here, we have the force F required to move an object varies jointly as its mass m and acceleration a. If F is equal to 120 when m is 4 and A is 6. Find F when M is 5 and A is 8. Now based on this one, so let's write it first according to its formula and variables. We have F is equal to K M A. Now first, before we proceed to the second part of the problem, let's find the constant. For F, we have 120 equals K times M is 4 and A is 6. So let's have the shortcut for this one. K is equal to 120 over 4 times 6. Now 4 times 6 is 24, so we have K equals 120 over 24 is equal to 5. So the value of the constant is 5. Now based on this, let's write first K equals to 5. F here, based on the second part of the problem, is what we are looking for. So F is missing. M is 5 and A is 8. So for this one, you could just directly substitute them. So 5 times 5 times 8. Now 5 times 5 times 8 is 200. Now since we're dealing with word problems, in force, the unit for this one is N. So our final answer would be 200 N, which stands for 200 newtons. And this is our answer.